Where am I from?
Taiwan.
Yeah.
It's not really dumb, but they speak Taiwanese or Chinese.
They speak dialect. Dialect is Chinese. Dialect is Taiwanese, and they also speak Mandarin. They are forced to speak Mandarin, but now there's different party within Taiwan. There are people pro Taiwan and there's pro China. They're not like really pro China, but they have two different parties. So when one party take over, they start say you're allowed to speak Taiwanese as a dialect, but also most of the time you speak Mandarin. Yeah, I mean I grew up speaking Taiwanese, and I also know how to speak Mandarin, so it's just different dialect.
You talk it at home.
I can speak both. So it's like you speak Spanish and English sometimes. So yeah, what we're gonna do is we're gonna go to so what we're gonna talk about is hold on, let me turn this small and make this big. Okay. So just kind of review everything. You probably have to write it down. If you have write it down, great. If you don't have write it down, I'll just review again. So sometimes I will tell you that I use the height function. So this is a height at a given time. And sometimes I use S of t. Just like if I do projectile, I can use either one, but a lot of time I talk about height. But this one just position. So they are roughly the same. Just so you know, I might interchange sometimes, depends on the situations. So H of t and S of t can be equal to each other at this case. It's more like a more like one to the other, not the other way to the other way back. So just so you know, I do let you know is they are the same for now. So S of t is a position at given time. So they are probably, at this case, we're gonna say they are the same. Now S prime of t is equal to velocity. And that means velocity at given time. And which kind of velocity? The specific time of velocity, this is called instantaneously. I think that's how to spell. I'm not sure. Or it can be double prime of t, which is v prime of t, which is also known as a of t, which is equal to acceleration. In terms of projectile, acceleration always the same, which is 9.8 meter per second square or 32 feet per second square. So acceleration. So those are the things. Now, in order for you to find out one layer lower is you are taking the derivative. So you're taking derivative this way. And if you want to go up from acceleration to go to velocity or go from velocity to position, that is integral. Or also known as antiderivative. Okay, so that can go back. Okay, so those are something that we already give. We also talked about in terms of free fall last week. Free fall is going to be negative 16t squared. This is a free fall situation. That means you can use this formula to calculate, you know, how deep, how high is a cliff or a building by dropping something and just measure the time. Okay, so that is a very easy formula for you to give. So you just have to count up the time and just plug it. Far as projectile goes, so projectile is going to be h of t is equal to negative 16t squared plus v0t plus s0. This is one that we end up with. This is due to gravity. And V0 is V0 times time is basically the displacement due to initial velocity. So this is the initial velocity. And this is called initial position. Okay, so you can have the situation come up. So we want to talk about one more thing. Say, what is average velocity is? Average velocity is gonna be, please make sure it's not average of velocity. It's actually average, it's actually over average the distance. Is S of B minus S of A over B minus A. Now it's not V of B minus V of A because this is bad. It's actually changing position. Please understand, average velocity is changing position over changing time. If you have changing V over changing time, it's actually called average acceleration. Normally, you don't need that average acceleration, but in AP exam, it's being asked before. So please don't get confused. Now I'm gonna create a situations. In this situation is I'm gonna say, Mr. Ye, is throwing a ball straight upwards. So it's not going at angle upwards at 96 feet per second. And that sounds like a lot, but it's not a lot. A human can draw 96 feet per second, which is roughly 65 miles per hour. That just kind of a throw between first base to second base. You can reach that far without ball dropping. That means you can probably more likely draw 65 miles per hour. High school baseball pitchers throwing about 85 to 90. So 25 miles slower, it should be very reasonable. But I can try tomorrow. So because I'm bringing a speed gun tomorrow. You can see how fast you can run. Yes, you want to see? Okay. You want to see how fast I can run? Okay. Mr. Ye is throwing a ball straight upward at 96 feet per second on top of 256 feet tall building. So this is what a word problem will start saying. The Mr. Ye is throwing ball straight upwards. We're not drawing at an angle. We just toss it up as hard as we can. Now we're gonna ask you multiple part about this question. A, can you construct, sorry, that was really fun. Construct a projectile position functions. Very easy. So everybody should be able to do that. B, I'm going to ask you like 6 different parts. B, can you find a height when t equal to 2? C, can you find the average velocity? Between t equal to 2 and t equal to 4. It's possible to find that. Definitely it's possible, but the answer might be very surprising. This answer is going to be surprising compared to what you usually get. So think about how do you do this, right? D. Can you find the time when the ball hit the maximum height?
Is it nearest second?
Huh?
Nearest second?
No, you want to find the time. Yeah, seconds. We're going to say seconds. E. We got multiple part, like I say. Can you find the maximum height? F. We're going to have two more parts. F and G. That's it. Can you find the time when the ball hit the ground? Lastly, can you find the velocity of impact? What I mean by impact is when the ball hit the ground, I want to see how fast is it. How fast is it? So multiple parts, it's pretty easy. I want you to try it first. So construct a projectile position functions. S of t is equal to not just 256. It's an equation.
Oh, can I say it?
Sure.
Negative 16 t squared plus 96 feet per second t plus 256 feet.
Yep, that's it. 256, that's it, no t. So that's a position function.
I meant feet, not t.
Oh, feet, okay. So find the height when t equal to 2. Do you know how to do that? Just plug in 2. It's very easy. So negative 16 times 2 squared plus 96 times 2 plus 256. That's equal to negative 64 plus 192 plus 256. I think it will end up to be 384. Not sure. Okay. So you can find the height. C. Can you find the average velocity between t equal to 2 and t equal to 4? The answer might be a little bit surprising because you don't think that can happen, but it can. Because this question's worded is very... Marco and Luke Davis isn't on the varsity team debate.
Yep.
3rd place. Nice. It's easy to work with Luke Davis.
He's getting better.
I think his social skill had improved so much since last year. Like, improved.
It's because of debate.
Is it debate? Yeah, I'm actually really proud of him. No, I teach BC.
Wait, so what was he doing? Wasn't he doing double block?
He's doing BC. He did Calc AB by himself at 8th grade. He got a 3 by study by himself. Oh, by the way, I invited 3rd grader here this Friday for math competition. So you're gonna see the 3rd grade kids.
I would not want to see that.
He's really nice. He's really nice.
I know, but
Wait,
he would definitely be real. Yeah, it's shameful.
I got. Is he Asian?
He's Chinese. He will explain to you how Calc2 work.
Calc 2? Ah, yes.
This,
Is he coming during BC?
Huh?
Is he coming during BC?
No, but you saw him last year, right? Did you saw him? At the last period, like he's a little Asian kid. Him and his sister come in to my class. I sneak him in the high school.
He's a freshman. Everyone would believe it.
Yeah,
Is it for C? Is it 45?
it's actually a 0.
What? Oh.
It's a S of 4 minus S of 2 over 4 minus 2. Nothing to do with velocity. But if you plug in 4, I think you're going to get 384 minus 384 over 2. That's actually 0. But how can average velocity equal to 0? If you think about it, can it happen?
How'd you get 384?
If you plug in 4, it's going to get 384. I did it before, so you can double check my math though. Can it be possible to have average velocity of 0? Matthew says yes. When?
When you start at the 6 spot.
You start like when you're throwing something up, right? So something is like on the way up here and going to here, but on the way down is at same positions. If it's the same height, guess what? There was no displacement. There was no displacement at all. So in this case, it can be 0. Can be 0, can be equal to any other numbers, but 0 is possibility. And if you want to understand when it going up, they have a positive velocity. When it comes down, has a negative velocity, but they are the same velocity. But you're gonna have one positive velocity and one is negative velocity. Yes.
If they're at the same like height at that time, at the 2 different times, does that mean the like middle of those 2 times is the maximum?
You are absolutely right, and that's how they. That's how sometimes they give out SAT question like that. They give you a parabola has x-intercept at -2 and x-intercept at 4, and then they ask you to find vertex. You just take the average between 2 x values and plug into the function to find the vertex.
and be -2.
Okay, so how do you find the time when the ball reaches maximum height? Danny?
So you can do that, or you can do -b over 2a, and negative the x value, which is 3, and then you do s of 3, and then you evaluate.
Yeah, negative b over 2a is definitely one way to go, but right now we're doing calculus. So how did you do it in calculus? How do you find, using calculus, how do you find the time when the ball reaches the maximum height? Horizontal tangent, good. Why?
Well, the at the vertex, the tangent will be 0. So we just set the derivative equals 0.
Good. If you set the derivative, so s of t is equal to -16t squared plus 96t plus 256. Now, what you do is you can take a derivative of this. It'd be -32t plus 96. And since v of t is equal to 0 at the maximum height, so it'd be -32t plus 96 equal to 0. T is equal to 3. You can plug in the 3. If you plug in 3, it will roughly equal to -16 times 3 squared plus 96 times 3 plus 256. I think you're going to get 400 feet. That's actually pretty easy. Just plug into original function. You're not plugging the derivative functions. Now, how do you find the time when the ball hit the ground? How do you find the time when the ball hit the ground? I know you know, I need other people to tell me. Maybe Ron Garage? Maybe Noman? Maybe Shelton?
Not t equal to 0.
Not t equal to 0. That's when I start. Maybe on the right track though. Ground. Yes, Reba?
You just do the same equation but without the 256.
No. Without a 256, yeah, that means you just you are on the floor, throw it up. So take less time to come down. Yes.
Yeah, I'm going to say it.
Equation equal to 0. Good job, Nicholas. That's a very awesome job. S of t equal to 0. So 0 equal to negative 16t squared plus 96t plus 256. Is it possible for me to solve this? I won't factor out just the 16. If it's me, I'll factor out even the negatives. Yeah. That makes it a little bit easier to factor. And that's going to be t squared minus 6t plus 16. Or minus 16, sorry. Minus 16. And I can do t minus 8 and t plus 2. And t is equal to 8 and t equal to negative 2. But this one's not a solution because that's out of physical constraint. Physical constraint is like you cannot go back in time. You cannot set t equal to negative 2. But, so that's why you use the t equal to 8. Now, how do you find the velocity at the impact?
Got the negative 16. I want to multiply negative 16 by the t. Negative 8. You factor that out.
Yeah, but negative 16, if you divide it by both sides by negative 16, it's going to become 0. So the negative 16 is no longer matter. You just need to find the when they cross the x. Okay, so how do you find the velocity at an impact? Yes.
You have to take the derivative of the projectile condition function, so you get negative 32t plus
So v of t is equal to negative 32t plus 96. And what do you do with that?
you just you set that equal to 0.
No, we already did that on the last question when we find the maximum height. We want to find the velocity. Yes. Plug in 8 is good. Because you want to know what happened at 8 seconds. What's my instantaneous velocity? This is a little bit different because this case is the instantaneous velocity. So that's equal to negative 160, which is feet per second. That is the velocity at the impact. That's when they hit the ground, and you can see how fast it hits. So there are multiple parts that you just have to understand. On the test, more likely one question like this. But if you realize I'm not taking derivative with respect to x, we actually taking derivative with respect to time now. It's d to the dt, not d to the dx. So there's a slight difference, which is going to build in for tomorrow. Now, how much time I have? 17 minutes. So what we're going to do is we're going to talk about the whole, all the relationship that you're going to be deal with in 2 different topics. One is related rate, one is optimization. Now, if you have friend in double block, they will tell you related rate is probably the worst thing that they have seen so far this year because it's all pure word problem. So you had to figure out how to deal with the word problem in this whole week. So this is just the very beginning stage of it. Yes.
So I understand how we got t equals 8 for our f, but why wouldn't it be 6? Because if it takes 3 seconds to go up, wouldn't it just be the same thing, like a graph?
So can somebody answer a question? I know the answer.
What do you say?
It says take 3 seconds to go up in the highest point. Yeah.
Yep. Sorry.
So Reba was right. You start at a height.
Yep. No, that was
If you start on the ground, then you will exactly, if axis symmetry is gonna split.
yeah.
Is any question before I move on to relationships? So tomorrow we're gonna study something called related rate, and we're gonna talk about a precursor of related rate. So related rate. And this is tomorrow. But today we're going to talk about just relationships between geometry relationships. So this is today. Today we're going to talk about this. So what do we need? Why do we need to study geometry relationship? Because we have to know them all before we start. And also going to help you use for something called optimization, which is Katie will tell you, right? Related rate and optimization is the two hardest part of the calculus. Even though it's not on AP exam so much though, it's maybe like one question, maybe multiple choice, maybe. Yeah. So it's not a big a deal, but far as application, if I'm teaching you real calculus, unlike the diluted AP calculus, they're diluted, they're way easier. This relationship, the related rate is actually quite important. That's actually how all the things make sense. So let's talk about three different shape. Square, rectangle, and circle. And let's start with this basic shape. And I like to start with basic because some people actually don't know this. So let's say its area of a square is what?
Or side squared.
Side square is better because they have the same side. How about perimeter?
Side times 4.
4 times side. Okay, how about rectangle? Length times width, and perimeter is what? Very good. Circle is what? Pi r square. How about circumference? 2 pi r. And do you guys know in circle has a very interesting relationships? If you take a derivative of the area, you actually get circumference. Don't ask me how, but just know that's a fact. If I take it down to 2 in the front, it's 2 pi r. But they not only apply in circle, they actually apply to sphere as well. So if you take a square, now I'm going to take the volume of cube, so that I'm still talking about the same type of shape, but except it's three-dimensional now. Rectangle prism. I think it's called prism. And this is sphere. What is the cube? A volume of cube? Side cube. What about the surface area of a cube?
That's side times 3 side. 3 side. No, it's not. No, don't listen to me really quick. Give me a second.
6 times side squared.
6 times side squared. Thank you. There's 6 sides in a dice. Right? 1, 2, 3, 4, 5, 6. Okay, 6 sides to the dice. Rectangle prism is going to be volume is equal to length times width times height. That's the one that you guys always think of. But surface area is a hard one though. What is surface area of rectangle prism?
6 times width times 3 times plus other length times width. No, sorry. Length times width times 4 plus other length times width times 2.
There's a problem. You're assuming the two sides are equal. Yes, Sheldon?
2 times length, 2 then parentheses length times width plus width times height plus.
The reason being is if you draw a rectangle prism, it's gonna look like this. Oh. No, that was bad. It's gonna look like this. So the problem of that is there was top and bottom is gonna be the same thing, and there's front and back and left and right. So they are different things. So width, length, height. So there's top and bottom. Top and bottom is WL 2 times WL. WH is gonna be front and back, and LH is gonna be both sides. Mason, do you understand? So it's gonna be 2 times of that. Sphere, volume of a sphere.
4/3 pi r squared.
No. Pi r
Cube.
cube. Okay, what is surface area? Sheldon? How do you remember that? Actually pretty cool, right? Derivative of that is gonna be 4 pi r squared. Which is only work with a circle, it doesn't work with cube or rectangular prism, but a circle relationship, they are all the same. The next two shapes I want to talk about is cylinder and a cone. What is cylinder?
Volume.
Volume, yes.
Pi r squared times height.
And those of you guys still have a problem, remember that? Basically, you think about you stacking the quarter. If a quarter has an area of pi r squared, now if you stack 20 quarters, just have to multiply by the height of 20 quarters, and then you find out the volume. Oh, by the way, so you guys know, which one's bigger volume? If they have the same height, which one has a big? Hmm? You sure?
Absolutely, 100%. No, they're not the same. I'm lying. I'm joking. No, they're all the same. I am confident about this. Right?
Can
now.
you make up your mind?
I have made up my mind. They're the same.
Okay, they are the same. Okay. They are the same. It's called I forgot. There was something called I forgot something principle. I forgot. But yeah, in geometry class you actually learn about that. Surface area is tricky though. Surface area of a cylinder.
I think I got this.
8.
Revolve's got it.
I think that okay. They do 2 times pi r squared plus circumference times height.
Oh, very good, very good.
I'm 2 for 2.
Pi r squared. Pi r squared. Pi r squared is the top part and bottom part. Now, how do you know? This is the height, right? Now, how do you know that's the circumference? Because if you have problem visualize this, just think about this as a cylinder. If you form a cone and you expand it this way, this becomes circumference of the circle. Does that make sense? So you can actually expand that part. So it'll be
Really focused on the SAT about it.
they are.
There's like one. I went all the way in front. It was easy though.
So I hear it's 2 pi r because that is the circumference, this is the height. So it'll be 2 pi r times h. So it'll be 2 pi r squared plus 2 pi r h. And this is an easy question. And yeah, I wish I kind of go over this before the SAT, but Hurricane kind of ruled me over.
There was a
Okay, comb. Comb is gonna be. Oh, I think you are talking about. Wait, I think you're talking about a comb. I think those like pretty similar. Okay, so a comb. The comb has inside has 2 relationships, but let's talk about volume first. That's the only relationship I want to worry about. So, did anybody know what the comb volume is? What?
3/4 pi r.
No. Yes, Nicholas.
1/3 is circumference times height.
Almost is 1/3 times the cylinder. It's 1/3 of cylinder. So the comb is 1/3 of cylinder. And if you kind of visualize this, like think about if you have a same comb, right? Same size of comb. And if you have same size of the comb right in the middle here, and this is roughly 1/3, so it's 1/3 of pi r squared h. So 1/3, 1/3, 1/3. So it's going to be 1/3 pi r squared h. So that's an easy way to remember it. So just actually understand the easier way to remember it is much easier in your life. Try to understand things instead of memorizing things. Now inside the comb, it has a similar triangle inside the comb, which is we're going to talk about that later. Inside the comb, that has similar triangle. I'm going to talk about that. So if I have this, that just say is this is 5 and this is 10. And if I have water fill up to this moment, and we say the water height is 5, what's the radius? 2.5, which is half. So it's actually create a similar triangle here. So at this case, there is a similar triangle, which is this relationship. Inside a comb, there is a relationship like this, which is we're going to talk about later. If this is A and this is B, and this is C from here, this is D to here. So this proportion is the bigger triangle equal to B over D. So that's the relationship. It's called similar triangle relationship. On SAT, you're going to see this, except on SAT has different type of similar triangle as well. In SAT, you might see this.
That's true.
These two triangles are similar to each other too, but in different orientation. Why? Because this and this are alternative interior angle. This and this are alternative angle, and this vertical angle.
There's a question.
On this question?
Because I want to get where I have to take the derivative too.
Which one?
Alright.
All right, so yeah, so this is a some type of relationship. It's called similar triangle. So similar triangle on SAT, they are two different kind. They are the first kind, which is we use in calculus. The second kind we don't use in calculus, but it does happen. I want to talk about two more things. Pythagorean identity. A squared plus B squared equal to C squared. Very, very important for related rate. You're going to see a lot of questions on Pythagorean identity. The last one is trig ratio. Related rate, which is tomorrow we're going to do it. Trig ratio is going to be SOHCAHTOA. SOHCAHTOA. So sine theta is equal to opposite over hypotenuse. Very, very important. Cosine theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. Now, I want you to write something down right now. As far as related rate goes, This type of question only deal with how fast the angle change. How fast angle change, which is d theta dt. Also, make sure constant on the bottom. Make sure constant on bottom. And that's it. We end the day like here. So tomorrow we're gonna actually go into actually do problem. Today we just talk about relationship that you're gonna be using tomorrow.
I was on fire today.
You just need to show up to school, Reebok.
Yeah, I gotta go urgent, but this was the question.